Welcome back everyone, Patrick here, moving on to the next question dealing with quadratics, more specifically factored form quadratics. So this question, it's kind of unique, it's not too bad, you just have to follow the wording very carefully. So a point lies 3 units above the x-axis on the axis of symmetry of the quadratic y equals x plus 6 times x minus 8, and we have to find the distance from that point to the point on the parabola, on that same quadratic where x is equal to 7. So notice here what they're ultimately asking for is the distance between 2 points, and just as a quick review, if we got 2 points, let's say x1, y1, x2, y2, what is the distance between these 2 points going to be? Well, it's going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, this is from a previous unit. And so really what we have to get is the coordinates of these 2 points we're working with, and then finding the distance is going to be pretty easy. The question is, how do we do that? So again, we got to read this very carefully. So we're told a point lies 3 units above the x-axis on the axis of symmetry of the quadratic x plus 6 times x minus 8. So a point lies 3 units above the x-axis. So the x-axis is here. And so notice at this first point, it's going to be 3 units above the x-axis. So we know for sure that the first point we're going to deal with is going to have a y value of 3, right? Because a y value of 3 is 3 units above the x-axis. The question is, what's the x value going to be? And the x value is on the axis of symmetry. Remember, the axis of symmetry, what is that? That's the x value of the vertex, or the vertical line that cuts a parabola in half. That x value, it's going to be on the axis of symmetry of the quadratic y equals x plus 6 times x minus 8. So, writing this out over here, how can we get the axis of symmetry of this? Well, notice we can get the intercepts. Hopefully by this point you're fairly comfortable just looking at this and seeing that the x-intercepts are -6 and +8. But if you want to show your work, or if your teacher requires you to show your work every time, how you solve for the x-intercepts is you plug in 0 for y, and notice that you'll get a y value of 0 if either this bracket is equal to 0 or this bracket is equal to 0. So it's going to happen at x equals -6 and x is equal to +8. So for this parabola, the x-intercepts are at -6 and +8. So if we draw that out, just roughly, let's say that +8 is like over here, and then -6 is over there. So those are going to be the intercepts of this parabola. Now, where's the axis of symmetry going to be? We know the axis of symmetry, it's going to be the midpoint of these intercepts. It's going to be the vertical line that's halfway in between the intercepts. So the axis is going to be the 2 intercepts added together divided by 2. So -6 plus 8 is +2 divided by 2 would give us 1. Okay, so 1, an x value of 1, is the halfway point between -6 and +8. And notice that 8 minus 1, what is that? 7 units. And then from 1 to -6, notice that that is 7 units as well. So that's the axis of symmetry of this parabola. So going back to this first point that we're dealing with, a point lies 3 units above the x-axis, so the y value is 3, on the axis of symmetry of the parabola. And we know the axis of symmetry is this vertical line here at an x value of 1. And so that point, that first point we're dealing with, is going to be right there. So it's going to be at 1 and 3. Okay, so as I mentioned at the beginning, you just have to read this very carefully, step by step, and understand the information that they are giving you. Okay, so that first point we're going to deal with is 1 and 3. So what we have to do is we have to find the distance from that point, 1 and 3, to the point on the parabola where x is equal to 7. And so where's that other point going to be? Well, it's going to be on this parabola when x is 7. So we can find what the y value is by plugging in 7 for x. And so we'd end up with 13 times -1, which would give us -13, like that. Okay, so the other point is going to be 7 and -13. All right, it's going to be the point on the parabola, on this parabola here, where x is equal to 7, and we found the corresponding y value by plugging in that x value of 7 into the equation. So this other point, if we go back to this diagram, let's say 7 is like here, let's say -13, it's like down here, it's going to be over here. 7 and -13. So we got 7, -13, and then we got 1 and 3, and what we got to do, we got to find the distance between those 2 points. Right, so from this point, it's pretty easy. It's just going to be algebra. Right, we can label these. Let's label this x1, y1. We could label this x2, y2, and then just plug it into the formula. So we'll have the square root of x2, which is 7, minus x1, which is 1. That's going to be squared. Then we'll have y2, which is -13, minus y1, which is 3, and then that's going to be squared, like that. So we'd end up with 7 minus 1 is 6, that's going to be squared, plus -13 minus 13 would give us -16, and then that's going to be squared. And so doing the algebra here further, we'll have the square root, 6 to the power 2 is 36, -16 to the power 2, that would give us 256. And so we'd end up with the square root of 292. So that ends up being the final answer right there. And then you could simplify this, so you could either put this in decimals. The decimal is going to be approximately 17.09. Okay, the distance between these 2 points. You can also, your teacher may or may not want you to simplify radical expressions, and we've done that before in previous videos. So if they don't, you can just ignore this part, but if they do, you can actually simplify this, because root 292 we can break down into root 4 times root 73, and then root 4 is 2, and then we'll have 2 root 73. Right? If you plug this into your calculator and this into your calculator, they're both the same thing, except this here is actually a simplified radical expression of this, and then root 73, you can't simplify that any further. But again, if your teacher doesn't require this, you can just skip that part, but in case your teacher does, I've gone through these kinds of exercises in the previous units a lot, where we dealt with these sort of algebraic calculations of distance, midpoints, etc., etc. Okay, so either this, this, or this, one of those 3 answers you will see in a question, in a textbook question, like this. All right, so as a quick review, what happened was we had this parabola. Now, if we actually draw this parabola, the axis symmetry is 1. If we plug in 1 there, we would end up with 7 times -7, which would give us -49. So let's say that's like here. That's the vertex. So if we draw this parabola, I should have maybe done this earlier in the question. That's how the parabola is going to look. So this is the axis of symmetry on the parabola, and this point is on the parabola, 7, -13, and then this point is 3 units above the x-axis on the axis of symmetry, which is the x value of the vertex, which is 1. And then once you have those 2 points, you just have to find the distance between them.